In this lecture, we will see the layout of a AND or invert gate, that is AOI 21, which is drawn from the twisted schematic. So at first, open the terminal window by pressing Ctrl, Alt and T. Then type magic, press enter. Now this is the layout window. Since we will write the commands, so type grid. We'll draw the layout by using commands. Now in order to zoom in, press Z. Zoom out, press Shift Z. So here we need 3 PMOS and 3 NMOS, and among the 3 PMOS, two can be drawn together and one has to be drawn separately. So at first we have to draw the N-well region. So this is the N-well region. Then type paint N-well. Okay. Now after painting this N-well, the two PMOS, that is the first and the second PMOS, they have a common drain. So we can draw like this for two at a time, or we can even reduce this area up to this much, and then type paint pdiff, that is p diffusion layer. After this, we can place over here. We will leave some more space so that if we need to extend this, we can extend it freely. Then type paint pdiff. And for this extra portion, we can just erase. Okay. Okay, even we don't need this much for one PMOS, so we can eliminate this by typing erase and then type paint N-well. Now select this portion and type erase. Okay. Now similarly, we can just make a rough idea over here. Here there will be one poly, here there will be the second poly. These two will be the sources. This portion will be the common drain for two PMOS. Here this is one gate, then a source terminal and a drain terminal. So, but in the case of the NMOS, we have the source and drain. The source and drain common for the first two NMOS, and the sources of the second and third NMOS is in common. So we can directly select from here to here just for equity. And now type, paint, and diff. After painting the N diffusion layer, P diffusion layer, P and N diffusion layer, just zoom this. Okay. Now, now this is the first PMOS and second PMOS. So you can place a gate layer, two gate layers. Then type paint poly. This is for gate 1 and this is for gate 2. Okay. Paint poly. Okay. And over here type paint poly. Now the gates have been shorted. That means the three inputs are already given. They are already drawn. Now next the sources of the PMOS 1 and PMOS 2 are shorted. That is, they are connected to VDD. So type paint M1. Similarly over here type paint M1 and then from here to here type paint M1. So now the VDD layer is drawn. Okay, this is the VDD layer. Then this drain, this is source 1, source 2, drain 1, drain 2 are shorted. This drain is connected to the source of the third PMOS. That is, as we know, this is and or invert, that is A dot B plus C bar. So this is A dot B, this is A dot. So this is the A dot B part, that is the two PMOS in series, and this is the plus C part, that is the third input is in parallel. Okay. So now this is the source terminal and this is the drain terminal. So this is the source terminal, paint M1. So I'll short it over here. Then paint M1. Okay, these two are shorted. You can see here there is little disalignment. Okay, now these two are also shorted. This is the NMOS part. In the NMOS part, the drain of the first NMOS and the drain of the last NMOS, that is the third NMOS, they are not connected. The source and drain are shorted, and this drain is connected to the drain of this PMOS. So before going for that, this is the source of these two. You can do one thing just for a good alignment. We'll short these two S2. So I'll erase this part. Okay, so that this looks a bit aligned and proper. So from here to here. Okay, from here to here. Type paint M1 here also. Paint M1. Okay, these two are shorted, and this is the ground. These two sources are shorted. Here this is the common source and drain. This is the drain terminal. This is shorted. Now this is one drain. This is another drain. This is drain of the third PMOS. This is the drain of the third NMOS. So from where will we obtain the output? We will obtain the output from the common drain point of the this third PMOS, third NMOS, and the first NMOS. As we have seen this from the schematic itself. So at first we'll short these two. Okay. Paint M1. Extend this. Then over here. Paint M1. Okay. Then from here to here. So these two drains are shorted. Now paint M1. Okay. Now you can see this drain, and this drain, they are shorted. Now we have to place the contacts. So just zoom in. You have to place the contacts in a square format. So select the area, type, paint. This is the P diffusion layer. So this is P diffusion contact. This is the P diffusion contact. Before that, okay, paint PDC, paint PDC. Similarly, we have two more over here. Paint PDC, and similarly over here, paint PDC. Okay, and then we have the end diffusion contacts. So paint NDC, paint NDC, and another one over here. Okay, now we know this is the output point, these are the inputs. So we can do one thing, we can just put this short poly, then paint poly, paint poly, and this is the output. Paint M1. Okay, so the output is taken from the common drain. Okay, we have to place another contact for the VDD layer. That is the N well contact or the N substrate contact. Here also type paint NWC, and over here we have to place the P diffusion, the P substrate contacts or the P well contact. Paint PWC. Okay, now after placing all the contacts, type save AOI 1. So I would like to find any DRC errors. There are no errors in AOI 1. Okay, after that we have to do the labelings. This is VDD, so select a square or rectangle, right click, label VDD, and this is the ground. So label ground, then label VA, then label VB, then this is label VC. So Z is our output, so I'll type label VZ. Okay, now save, extract. So extraction is done, AOI1.ext, then extract to sim. So the sim file is also extracted. Now after extracting the sim file, next we have to simulate this in the IR sim. So type IR sim AOI1.sim, then W, that is watch, VA, there are three inputs, VA, VB, PC, and the output is VZ. Then display, so all are XXX. Then what will I give the combination? Okay, let me give low to all three, VA, VB, and VC. What will the output? It's showing VA, VB 0 0. So when A is 0, B is 0, this is A dot B, VA dot VB, output is 0. Then we have OR. This is the AND output, then this is the OR input. So the total final output will be 0 again. So this is AND OR invert. So whatever the output from here we'll get an invert of that. That is, we got 1. Let me give high value to VC. So certainly we'll get the output as 0. Okay, why? This is 0 0 and output will be 0. This is 1, so OR output will be 1 and the invert will be 0 again. So if I give VA, okay, this is high for VA. Again that will be 0 because VB is 0. Then high for VB. Again that will be 0 because output here is 1 for AND. Output for OR is 1. Again we'll get this invert. If I give low for VA and VC, then I'll get 1. Why? Here the output is 1. Sorry, the AND output is 0. OR output is 0. So the invert will be 1. If I want to see the waveform, then I'll type ANA, VA, VB, VC, and VZ. So here you can see this is 1 1 1, output will be 0. Here 1 0 1, output is again 0. 0 1 0, output 0. Here 0 1 0, again output became 1. If I want to zoom it to full, this is the obtained output. So this is the layout. If I zoom out, You can see this is the layout of a AND or invert 21, that is AOI 21 gate, and this is the waveform of it. If we want, we can create the spice file by typing extract to spice, then type exit, then vi aoi1.spice. So you can see this is M stands for MOSFET. The first one was a pipette. Since we were very careful about the length and the width of the PMOS and the NMOS, you can see the W by L ratio is same for PFET as well as the NFET. Then here this is the area of diffusion, that is 319 for the first one, the first PFET. And so you can see there are three PFETs, 1, 2 and 3. 3 NFETs, 1, 2 and 3. That was what a schematic. In our schematic we had used 3 PFET and 3 NFET. This is the area of diffusion, this is the perimeter of diffusion. This is same for the substrate. This is MOSFET 1, this is VDD, then VB, and similarly over here for others. So I can press colon WQ. If I want to see my magic file, the layout, type magic AOI1 OI1.mag, then press enter. Mag is extension file. So you can see this is the layout. Press Z to zoom in. So this is the layout of a AOI gate. Now let's see the layout of a AND or invert 21 gate from the untwisted schematic. So at first we have to open the terminal window by pressing Ctrl, Alt and T, then type magic and enter. So this is the layout window and this is the TKCon window. So here we will not use any commands in the TKCon window, especially for drawing the layout. Rather we will use the toolbar. So go to options, click on toolbar. So instead of typing, we can use the toolbars. We can use the layers from here directly. And now in order to grid in, press G in your keyboard. If I press G again, this will go back. In order to zoom in, same shift Z. Zoom in we have to press Z, and in order to zoom out, shift Z. Now when we are trying to draw the layout from the untwisted schematic, we have to place the NMOS and PMOS as it was there in the untwisted form. So if I select this area, then have to select the anvil. This is the anvil. So we have to middle click in the mouse. Since this is a AND or invert, in the AND or invert we have the AND means the NMOS is in series and the PMOS will be in parallel. So this is one PMOS, this is another PMOS. So middle click on the anvil, and the third PMOS will be in series with these two PMOS. This is A, this is for B, this is A dot B, this part is A dot B plus C. So when there's a plus operator or when there's a OR operation, we'll use a series PMOS. So middle click on anvil. Okay. Now before going for N diffusion, we have to draw the P diffusion layer. So select the area, then middle click on P diffusion. Similarly over here, then over here. So these three are the three P diffusion, the P MOSFETs. And when we talk of the N MOSFET, the N MOSFET, the two N MOSFET, that is the A and B, they are in series. So middle click, okay, and the third one is in parallel. So we'll place it over here. Then middle click on the N diffusion layer. So you can see these two parallel, then the series, these two series, and this is the parallel. Now since this is A and this is A, this is B and this is the B part, this is the third input C. Now after drawing the PMOS and the NMOS layer, this is my PMOS one, this is my NMOS one. So these two gates are shorted. So zoom in. Then you have to middle click on poly. Similarly over here, middle click on poly. These two gates will be shorted. Then these two gates will be shorted and these two gates will be shorted. Then from here, then we'll click on poly. So A, we have already obtained A. Now we have to go for B. Then middle click on poly. Similarly over here. Then from here to here. This is a 4 width. Either we can go this way or we can go this way also. This way is better. Then middle click on poly. You have to connect these two from here to here. Okay. Now A and B gates connected. Now C has to be connected. Then middle click on poly. So since this is the extra layer, so select the area, then middle click. Okay. Now the gates are already shorted. Now the sources of these two PMOS is connected to VDD. So select the area, then middle click on M1, then from here to here. Middle click on M1. Okay. Now this is the VDD. Now these two drains are shorted with drain. These two drains are shorted with source of the next PMOS. So select the area, and we'll click on M1. Then from okay. Now this drain and these two drains are shorted. So select the area, then middle click on M1. Similarly over here, then from here to here. it will click on M1. Okay, now the drains are shorted. And similarly, this is drain, so this is the source, this is the drain of the second NMOS, so these two are shorted. Then middle click on M1. These two sources are connected to ground. Then middle click on M1 again. So connect these two. Okay. Now we have to place the contacts. Middle click on, this is the P diffusion layer, so this will be the PD contact. PD contact. Have to undo this. So type undo. And middle click on the PD contact. PD contact. Then PD contact. Similarly over here and here. Okay, after placing the PD contact, we have to place the ND contact. So select the area, then middle click on ND contact. Then middle click on ND contact. And over here. Okay, now this is the VDD, so you have to place some contacts over here also. So select the area, middle click on N substrate contact. Similarly over here, you have the P substrate contact. P substrate contact. After placing these contacts, type save AOI 2. Then this is input 1. So make an extension poly, and this is the third input poly. This is the common drain, which is the output. Okay, Now this is A, so zoom it, take a small square, right click, and then type label VA, then this is VB, so label VB, this is the third input, that is VC, so type label VC, and this is the output terminal, so type label VZ. Now next is label the VDD and ground. This is the VDD layer, right click, then type label VDD, then we have ground, so type label ground, save. Let's see the DRC errors. There are no errors. Then extract, ext file is generated, then extract to sim file is generated, then extract to spice file generated. Now in order to see the sim file, or in order to work in spice, we have to use some commands. So type irsim, irsim, and or invert to dot sim, the file that we have just generated now. W for watch, VA, VB, VC, and VZ, the three inputs and the output. Then D for display, so we'll get XXX, that is the default value. Now if I type low, VA, VB, VC, then type S for step, then the output will be 1, obviously, since AND of 0 0 is 0, OR of 0 0 is 0, so the invert will be 1. Now if I give a high value to VC and then see, the output of the AND is 0 and the output of OR is 1, so the invert will be 0. If I give high value to VA and VB, then again the output will be 0. If I give low value to VC, then my output will be 1. Low VC, then S. Okay, this is 0. This is the OR operation. So the output of the AND is 1 and this is 0, so the output will be 1 and invert will be 0. So I have to give low value to either VA or VB and then S. So the output will be output of the AND is 0, this is 0 and this is 1. If you want to see the waveform in the analyzer, then type ANA, VA, VB, VC and VZ. So you can see this in 1 1 0, 1 1 output is 1 and this is OR 0, so the output will be 1. The whole A dot B plus C output will be 1, so the invert is 0. here a dot b is 0 and a dot b plus c is also 0, so the output is 1. If you want to zoom to full, you can see this is the whole waveform. This is 1 1 1, the output will be 0. This is 1 1 0, output again 0. Now just close this. Okay, you can exit. So type exit. After exiting, type vi AOI2.spice. So you can see again the pipette and NFET WL ratio is same. The area of diffusion here is a bit less, 308, and you can see this is VZ, VC, ground, NFET. Okay, you can see the spice file. And if you want to see the layout, then you have to type magic AOI2.mag. So this will load the layout. If you want to zoom in, then press Z. So this is the final layout of a AOI 21 gate. Now let's see the layout of a AND or invert 21 gate from the twisted schematic without using the commands. So at first, open the terminal window by pressing Ctrl Alt and T. Then type magic and press enter. So here we will use the toolbar present in the layout window in order to draw the layout. So in order to open the toolbar window, go to options and then toolbar. Now in order to grid in, press G. This is how you grid in. Now in order to draw the anvil, select the area and then middle click on the anvil. Zoom in. Now we have to place two PMOS in parallel. So two PMOS that have a common source and a common drain. So select it and then middle click on P diffusion. Then you have the third PMOS. So select the area. Select the area, then middle click on P diffusion. Then of the same length, we have the N diffusion layer also. Then middle click on the N diffusion layer. Similarly, over here, select this area and then middle click on N diffusion layer. Then you have to erase this part, then middle click. Okay, now I have to place the two poly layers, that is the two gates. Then middle click on poly layer. Similarly over here, poly and poly. Now Shift Z. Then these two layers are connected. The VDD. Then middle click on M1. Similarly over here, middle click on M1. So this is VDD. Then from here, M1, M1. If you don't want to keep this extra portion, you can just eliminate it. Then connect from here to here. This is the ground. Then after this, middle click on M1. This is connected over here. M1. Then this is the common drain that has to be extended up to here. Okay. And this is the common ground. So directly you can connect from here to here. So this is the ground. Now you have to place the contacts. Select the area, then middle click on P diffusion contact. Then we have the N diffusion contact. N diffusion contact. Okay. Now here there will be one contact, that is the P substrate contact, and here there will be a contact, that is the N substrate contact. So I have to save this, so type save AOI 3, and we want to label this is VDD, so we'll label VDD. This is ground, so label ground. This is first input, this is the second input, this is the third input, and this is the output. VZ. Now save it and then find the DRC errors. There are no DRC errors, so you have to, before going to extract, you can just see the whole layout again. Extract, then extract to sim, and extract to spice. Okay, so again you can go for the irsim file according to requirement. This is finally the layout of a AOI 21 gate. Now in order to open the irsim file, we have to type irsim AOI 3.sim. Then you want to watch VA, VB, VC and VZ, the inputs and the outputs. Then display, you have the default value. If I give low value to VA and VB, I want to see the output. Since I have not given any output to C, it's showing me X as the output value. So high C, then S. You can see the value is 0 0, output is 0, 1 and 0 is 1, 0 0 and is 0, 0 and 1 or is 1, and the invert is 0. If I give low value to VC, then I'll get 1 as the output. This is the output. If I want to see whatever I had given now, you can type analyzer. So earlier it was X, so you can see over here, this is 0 0 1, output 0, 0 0 0, output is 1. So this is the waveform. One exit, type exit. If I want to see my file again, so type magic AOI3.mag and then press enter. So this is the final layout of a AOI 21 gate. You want to zoom in. Okay, this is the layout of a AOI 21 gate.